Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. It's a video on quadratic word problems, in particular those problems in which the equation is not provided. Rather, you have to make the equation based on the information given. It's question number 8 from a worksheet on those problems. So let's look at that question. It says Chris cuts half a rectangular lawn where the lawn is 40 meters by 30 meters, by mowing strips of equal width around the perimeter. Jerry cuts the small rectangular left over. How wide a strip does Chris cut so they share the work evenly? So let's get a feel for what's happening in the problem and then we'll start to formally solve it. So we start with a rectangle that we know is 40 meters by 30 meters and that represents someone's lawn. So Chris is going to cut strip around the perimeter. So I'm just going to kind of try to imagine that. So now if I shade all this in, this is going to represent what Chris is going to do. So Chris is going to cut this strips or a strip along this side and then this side and then this side. And he's going to end up cutting this weird sort of not quite regular shape. So he's going to cut all that red area away. And what's left over is this inside area, a nice rectangle, and that inside area is for Jerry. So Chris cuts a weird looking shape. It ends up being the perimeter, effectively the perimeter of a rectangle, and Jerry gets the little rectangle left over. And we know that Chris cuts half, or put another way, they share the work evenly. So we know that the area of the whole shape, we can calculate that. The area of the whole shape is 40 by 30, which is 1200 meters squared. So each person is responsible for half of that. So each person between Jerry and Chris is going to be mowing 600 meters squared. So we'll use those calculations, I'm sure, in our formal problem solving. So how are we actually going to approach this? Well, we always need to introduce an integer. Sorry, not an integer. We need to introduce an unknown. So we have to have some sort of variable. So if I reread the last sentence, it says, how wide a strip does Chris cut? In other words, how wide does this red section that Chris is cutting have to be? And we're told that it's equal width. So whatever this width is matches this width and is the same as this measurement and this measurement. And I don't know what it is, and usually that's when we introduce a variable. So the first step of this question is going to be to define a variable. We'll probably call it x, and x is going to represent the width that Chris cuts. So let's go ahead and start to formally answer this question, and then we'll see where to go from there. So we're going to let x be the width of the strip that Chris cuts. Oops. Put mows. And we're measuring in meters. And I'm going to add a little diagram down here, both for our purposes and for the person marking this. You know, you always want to make sure that it's very clear what you've defined x to be in case your wording maybe wasn't as clear. So this is what x represents. It's the width of the strip that Chris is going to cut. So now we have to figure out how to create an equation. Well, we know that the area, and again, I'm going to put this, I'm writing this again because I want this to be part of my full solution. The area of the whole lawn, again, was 40 by 30, which is 1200 meters squared. And therefore, the area each mows would be 600 meters squared. So this area here, again, let me kind of color it in red, that's 600 meters, and so is this. Now, if I have to find the area of an object, I would much rather find the area of a rectangle than find the area of this weird other red shape, which is like a rectangle with a rectangle cut out. So let's focus on actually not what Chris is doing. Let's focus on what Jerry's doing because that's a simpler shape. This is what Jerry's cutting. So I'll draw it again and I'll write Jerry. And if we could figure out the length and width of Jerry's rectangle, we'd be a long way towards solving this because we know that the area of Jerry's rectangle is 600 meters squared. So I wonder if we can figure out the length and the width that would represent Jerry's rectangle. Well, I've kind of messed up my picture here, but we know that this distance is 40. And we know that this portion of that distance was x, and this portion is x. So what would this portion be? Well, we have 40, and then we had to take away x for the strip here that Chris cut, and we have to take away x for the strip here that Chris cut. So this distance here would be 40, take away x, take away x. So it's really 40 minus 2x. So again, just to make this clear, let me erase that because it might be confusing. So what we have is we have a length that's 40 in total. It's made up of 3 pieces. One piece is called x, one piece is called x, and this unknown piece, again, that's the length of the rectangle we want, must therefore be 40 minus 2x because they have to add together to give you 40. So therefore we know the length of Jerry's rectangle. By very similar logic, we can talk about the length, the width of the rectangle. We know that the original width, let me get a different color here. We know that the original width of the whole shape is 30. But Jerry's rectangle is smaller because, sorry, did I say Jerry? Yes, because Chris cuts a strip of X units here and a strip of X units here. So Jerry only has to worry about this piece. And how big is that piece? Well, it must be 30 minus 2x. By the same logic we used up here, the whole thing is 30, but I've cut away a piece called X, and I've cut away a piece called X, so I'm left with 30 minus 2x. And so therefore, I can create an equation because we know that area is length times width. And we know that Jerry is cutting a 600 meter squared area, and the length of his rectangle is 40 minus 2x. The width of his rectangle is 30 minus 2x. And now we have one equation with a single unknown called x. So we can go ahead and try all the algebra math skills we can to try to solve for x. So on the right side of this equation, I'm going to do FOIL. So first times the outsides times the insides times the lasts. And now I'm going to rearrange it so it's in the proper order, collect like terms. So 4x squared minus 140x plus 1200. And then because we need to make the equation equal 0, I'm going to subtract 600 from both sides. And that gives me, oops, I forgot a 0 right there. So there's my equation, and we need to solve for x. Okay, so we could certainly try factoring, but let's just go ahead, use a quadratic formula. Again, I know a lot of you probably would have done that method, and this way you can check that you've done your math right. And already I've written something wrong. Let me fix that. So negative b, so negative 140, plus or minus the square root of negative 140 squared minus 4 times a times b, nope, times c, oh dear, all over 2a. Ooh, too many math problems today. Okay, negative and negative makes a positive, so that's positive 140 plus or minus the root of the discriminant, and we'll get to that in a second. On the bottom, I'm going to be dividing by 8. So now in my calculator, I'm going to be calculating the discriminant. So again, never bother I'm never going to bother typing negative 140 squared because we know that when we square something, it's always positive. So in my calculator, I just type 140 squared minus bracket 4 times 4 times 600. Close that bracket, and I have the number 10,000. Good. So now I'm going to split into 2 distinct answers, one of which is 140 plus the square root of 10,000, which is 100, divided by 8, and one of which is 140 minus 100 divided by 8. So doing that math, here I get x equals 30, and here I get x equals 5. So right away, they're both positive, so I'm not going to immediately say inadmissible, but let's look at our answers. One answer is that I cut a 30-meter strip, or rather, I guess, not me, it was Chris. Now, if we go back here to the slightly neater diagram, how is it possible for him to cut a 30-meter strip when there's only 30 meters to begin with. Remember, he's supposed to cut a strip like this and a strip like this, and there's only 30 meters. I mean, there's no way he can do that, and then how's Jerry going to share in the work? It doesn't make any sense. So, oops, wrong way. So it's impossible for him to cut a strip of 30 meters because it would mean that, well, it would be impossible. So therefore, we can say that this ooh, come on, come on. Even though 30 is correct algebraically, we still have to say it's inadmissible for this problem. And therefore, x equals 5 would be the width of this strip. So what's happening? Chris is going to cut 5 meters off of each side. And that should leave a rectangle. And then the area that Chris cuts around the edge is equal to the area that Jerry cuts in the middle. So therefore, the width of the strip is 5 meters. So make sure you're comfortable with uniform width questions. They're fairly common, and they all roughly have the same idea, which is that you let that unknown width, that uniform width, be x. Okay, I hope that was